tonight we're covering still modern times and how it fits in with the Yugas and all the things we're going to be seeing happening and technology and spirituality, and then how that progresses upwards into the higher ages. And tonight we'll get up to the golden age that's coming, and then the next class next week, our last class, I'll be covering the transition beyond the golden age and what happens beyond the golden age, and then we'll cover the last 12,000 years or so prior to this, the history of the last golden age descending to the last silver age. And then we had covered the last Dvapara Yuga, or Bronze Age, when we started, but now we're going back to way before that. And I kept that for later because I wanted you to understand the transition that's taking place gradually and what things are possible. And this way it's easier to understand. So right now we're still talking about our present ascending Bronze Age. And again, Bronze Age has nothing to do with the archaeological Bronze Age. It's the way Plato had originally mentioned the golden, silver, bronze, and iron ages. And in India, we know them as by their Sanskrit names. So this would be the Dvapara Yuga, the Bronze Age that we're talking about right now, which we finished the transition in around 1900, entered Dvapara Yuga proper in 1900, and we've seen all these incredible changes in the last 100 years, and now till around 4100 AD, is the whole length of still left of the Bronze Age. And the picture we're looking at there, I've been doing work in nanotechnology, and I had founded the Nano Manufacturing Tech Group. It's a national group, and so we had done some work in that. I give talks on nano, and so here you're actually looking at a mechanism at the nano level. The yellow atoms, you're seeing the yellow round things, are actually atoms. They're sulfur atoms, and in nanotechnology, you have this problem of stickiness, like kind of static stickiness. So how do you make a motor? But if you make them of the same material, they repel each other, and so it's easier to get kind of a motion like that going. And one of the people that was in our group, he had developed the first CAD system for nano design, and it's actually free to download off the internet. And so you can make these type of mechanisms with his CAD system, and very fascinating work. So things are moving ahead, in our technology that is just kind of mind-boggling. And I want to mention Ray Kurzweil. I use Kurzweil as a German word, so I pronounce it in German, so I'm from there. But anyway, Ray Kurzweil is, in his book, The Singularity is Near, When Humans Transcend Biology. It's a remarkable book. Ray is an incredible inventor. 12 honorary doctorates and awards from 3 U.S. presidents. One of the most remarkable people. He's the one that did all the software development of speech recognition. So that's what you have with Siri on Apple and with other phones. All that speech recognition comes from him. He started kind of all those things and many other things. If you look at his book, The Singularity is Near, a big thick book, the amount of information in there is unbelievable. It's hard for me to believe that one person can put all this together, And so one of the things he's talking about is one hydrogen atom can store 4 million bits of information. That's one hydrogen atom. Now realize a 2-pound rock using this capability could potentially hold the brain power of 5 trillion human civilizations, could perform the equivalent of all human thought over the last 10,000 years in 1/10,000th of a nanosecond, which is almost meaningless, it's so fast. So eventually one would think we would use the whole Earth as a computer, or the whole galaxy as a computer. But when our consciousness goes higher, we won't need computers, because we'll be capable of all that within us. So, but he's already seeing a lot of those things, and some of the things inside the atom, what's kind of amazing is one of the things is that we're already starting to examine and to use for computers, for computer memory and things, is the electron spin. And the spin is free energy. It doesn't use any energy. It doesn't require energy. So it's actually free energy that you can use. So we're finding more and more things. One of the things that was talked about was in molecular nanotechnology, the concept of synthesizing food from individual atoms. And so you take the regular elements that are available and put them together, synthesize them into food. And so you would need, in this sense, you would need no refrigerators or ovens, because the food would be made at the temperature you're going to eat it. And then when you're done with it, you just remake whatever you need. You don't, But the problem is that the technology, the way we're thinking today, is still a lot based on atheistic materialism, on what science was originally founded on. And it's a good thing they did it that way, because you really wanted to start at the base, at the very beginning, and build from there. So all you knew was, okay, you have material things. But then you begin to realize in science that we have quantum fields, we have gravity, and all these energy in space, and space itself being a substance. And so you have to kind of redo your thinking. In the same way with this, if you just synthesize food from things like that, you're forgetting that we get our energy, our food, from the sun. All the chlorophyll, all the conversion of energy for usable energy for us comes from the sun through our plants and other things. And so there's chi involved, prana, that kind of thing that's a little deeper. And gradually we're becoming aware of that. So this has to be incorporated into our technology. And so I thought it was interesting, because I've been using Kangen water. I don't know if you've heard of it. It's ionized water that is alkaline, and which is what you find in waterfalls or in rivers coming down from the mountains and things. It's alkaline, and it's also ionized. And how you feel good when you're around waterfalls, because the ions, the negative ions get things moving. And so I think it's kind of interesting that instead of just getting water, the Kangen machine and some other machines like it can actually generate the ionized water, which means that it's water that brings electrons inside our system to get the system moving. And so that's a step in the right direction. And I spoke about this a few months ago. One of the big things that we mentioned in the Dark Ages, the castles had no toilets, and how people would have all the refuse thrown into the streets, and the streets would get overfilled, and with human manure, and all that. And so now it's been like Alexander Cummins invented the first flushable toilet in the 1700s during the transition period. So we're starting to see, but now nothing has happened beyond that. I mean, sanitation is still pretty much the same. It's gotten more efficient and all that, but the concept is remained the same up till now. And so when Bill and Melinda Gates Foundation, they gave a lot of money to redo all this to make it easier for sanitation in third world countries, in places where they have a challenge, where there's no industry and nothing around, and what do you do? And so 75% of our water bill is the cost of handling waste and sewage. That's 1.25 trillion gallons of water. But with this new breakthrough, we will have 75% more water, because imagine no more pipes or sewer systems. If that were done away with, these high-tech toilets, they burn the feces and flash evaporate the urine, sterilizing at the same time. And they give back the packets of the urea for fertilizer, table salt, gallons of unused water, and enough power to charge your cell phone from your burning poop. Kind of, So I was thinking it'd be kind of funny if you're constipated, you can't, I need, my cell phone is running down. It's just crazy. But so the technology to process these organic waste, there are other methods out there already, but this is like one of the new things that's being developed. And imagine if you don't need sewage systems. All this were done, the way they're visualizing now. That's a whole new step into Dvapara Yuga, into the Bronze Age. And sanitation is one of the keys you look at, and where you are in the ages. As I mentioned back in ancient Crete, the civilization there on Knossos, how they had actually flushing toilet back there in 1500 BC, and Mohenjo-Daro and Harappa, the Indus Valley civilization in those times, 1500 BC or so, how they also had sewage systems and toilets and things, So here it says 1 megajoule per day of energy in human feces from burning, enough to power the toilet plus cell phones and lights. So this was developed by Lowell Wood, an astrophysicist at Lawrence Livermore National Lab. And so we can also see now with these type of things coming, why cities will become obsolete, because you don't have to be in a central location anymore. You can live anywhere you want. And Paramahansa Yogananda said, as we go higher into this age, the population will be much smaller, and people will be able to live wherever they want, And so we're going to start seeing these things happening. And I'll mention a few other things. One of them is femtotechnology. I talk about, give talks on nanotechnology. Nano meaning 10 to the minus 9 meters. And that's, 8 zeros and a 1, it's like really tiny, and if you think 10 hydrogen atoms put side by side is 10 angstroms, which is 1 nanometer. So 1 nanometer is 10 hydrogen atoms. So it gives you an idea of that size. But now, what's happening next after nanotechnology, And so I'm thinking about femtotechnology, is 10 to the minus 15th. That's what's the size of the nucleus of the atom. Then you're talking about femtometers. That's getting really small. And one of the things that we've developed, which is interesting, is we're able to do things in a femtosecond, 10 to the minus 15th seconds. And that's, imagine a 0 point, like then 14 zeros and then a 1, that's getting pretty tiny, And at that level, we're able to use lasers to film the bonding of atoms taking place in real time in femtoseconds. and it's never been capable of before. So we're able to see things that happen so fast that before we had no idea what was happening at that scale. So these are like more things happening that often we hardly realize all the technology that's happening nowadays. It's going so quickly, and none of us can really keep up. And we try our best. I'm on this Innovation Watch Committee for the Society of Manufacturing Engineers, where we try to find the best technologies around the world that are now coming into being and what are coming in the next 5 years online, and then letting businesses know which ones to look at. So I'm involved with that. Now I mentioned a moment ago about using the galaxy as a giant computer, and how in the higher ages we won't need to do that because our consciousness can handle that sort of thing. To give you an example, I want to tell you about John von Neumann. How many of you have heard of him? He's one of the founders of the modern computer, the ENIAC and all that. He is the one that developed many of those concepts, and also he was on the Manhattan Project. One of the most brilliant mathematicians. He was from Budapest, I think, and he was kind of the genius's genius. I know one time they were coming up with ideas at the Manhattan Project for the atomic bomb, and they were stuck. They had working out this one equation for the fission of the atom, and they couldn't get past a certain point. They couldn't solve it. And these are people that would win the Nobel Prize, in physics. And John von Neumann happened to walk by. He was working on a different project, and they called him in. Hey, John, can you help us with this? And he looked at it. Oh, okay, you do this. And the other people, didn't have a clue. And one of the most amazing stories about him was when some business people, very savvy business people, technologists, they wanted to solve a certain problem that's so complex that they came to ask him if it was possible to build a computer of such complexity to solve this particular problem. And they outlined the problem to him. And he just kind of went blank, like in a trance, saying, let me think about it, So for like 15 minutes, they're all sitting around, while he's, off in his brain, grinding away, and then suddenly he came to, and they said, well, is it possible to build a computer of such complexity that could solve this problem, give us this answer? He says, oh, you don't have to do that, I've already solved it. And he had. So that's the kind of idea I'm talking about, that as we go deeper, that time will come when we have that type of capability within ourselves. But the thing is, the way we work through the yugas is technology is the first step. That we need that. We need to work with technology and get deeper and deeper and deeper. Then more and more, how the energy and all that steps in, electricity, the quantum fields, and then you keep going to the point where mental power becomes deeper and deeper, and then we get into not just the wizardry of outer technology, but of the inner technology of the soul, and that's where we're heading. And other thing I wanted to mention is for over 20 years I ran the 3D printing lab at Northrop Grumman Aerospace, and did a lot of research in the field, and also was the international chair of the technology and things back in 2003. And so I wanted to show you some of the things I've grown, and to give you an idea of how our manufacturing process has changed, incredibly. It used to be in the dark age, everything was manual labor. Then now we're already so far into Dvapara Yuga that we just design something in CAD and then push a button and take it out of a machine a few hours later. And imagine that, like people would think even 100 years, even 50 years ago, that would be sheer magic. But now you design something beautiful and then boom, push a button and take it out of the machine. And I wanted to show you several things. One is the amazing capability of growing things that inside of each other, because you're growing layer by layer. So put all these pieces inside each other in the design in CAD, in the computer, and then the additive layer machine grows it layer by layer. Of course, it doesn't grow it like this. It grows it with each one equidistant to each other inside. That's the way the CAD model is made, and then it makes it like this. And then once you take it out of the powder, this is nylon. To be a little careful, this is kind of fragile. But when you dig it out of the powder after it's made, the things just fall down, So if I can pass this around. Another thing I wanted to show you is the brain gear. I grew this at Northrop with this is a $500,000 machine. Now they have these new little 3D printers that are like for a few $100 or $1,000, but this is like a $500,000 machine that built this. This is a carbon-filled nylon material, and what it is that comes out of the machine just like this, completely ready to move. You can build a clock, like a grandfather clock, and take it out of the machine and start it up. There's no assembly, because this is the way it's designed in the computer. It's designed to be equidistant in here, so it's not touching anywhere on any of these gears. Because if it were touching, then it would be fused together, right? But because it's all equidistant with a certain tolerance, you just pull it out of the powder when this thing is done. A laser builds this. It's a CO2 laser. It's a 100 watt laser, but run it around 10 watts. And so here you go. It's kind of addicting, but you get an idea. The other thing that's so important to show you is that you wonder, is this pretty artwork or what is it? Same with this thing here. This is not pretty artwork. What it is, I'm holding equations in my hand. These are like third semester calculus equations that, in high school you probably did some graphing of an equation in X and Y, and distance and height, and you have a like pretty curve or something happening. Well, some of these complex equations that are used for other things in technology, they actually, when you plot them in space in X, Y, and Z across a certain plus and minus range, you get these amazing, beautiful objects. Then remember, Plato, he talked about his Platonic forms that are out in the mind of God. Well, there's always this idea in philosophy, is mathematics something that we just made up, or is it something that's out there, kind of like pre-existing? And you kind of wonder, because when this kind of stuff can come out of these equations. And the beauty of it, instead of seeing it on the computer, we grow them now. And I have my students at Loyola Marymount University grow different types of equations as well as semester projects. So take a look at the intricacy of these things. I think like this one, for instance, if you follow one of these lines, it follows in here, follows around, follows all the way across, and it just keeps on going, all around. So it's quite amazing. So you get to hold an equation in your hand, right? And that's something that's only been possible in the last, this technology was invented by Chuck Hull basically in the mid-'80s, and we had the first machine available in 1989, 1988, And then I got involved in '91 with running the lab at Northrop, and so here you want to pass this around as well.
I think it went around already. Everybody's
And this one's done already.
Yeah.
Oh, that's right. Yeah. Okay. Now the other thing is you'll have to look very carefully, but this is a complete set of chess pieces on a chessboard that was grown by a friend of mine back east. They have a special it's called fine line prototyping, and they have the laser set a very fine setting to grow these parts out of a photopolymer, a light-sensitive liquid plastic with a UV laser. And so there's like a magnifying glass on the top that gives you a little idea. But like for instance, the rook actually has a helix going up the inside and a staircase around the helix. But you can't see that there, you know. So, but I just wanted to give you an idea of something that's happening that I'm involved in that's really part of this new age, right? So now to go a little further from a desktop fabber, as you could call it, or remember in Star Trek they talked about this kind of stuff, like something that would come in the future, and we're already doing it, you know. And but the next thing is on the nano level. We're going to be able to make these machines that make things out of the individual elements, and those would be like a desktop nano machine. And once we have one of those, it could make another one of itself. These things can replicate. In fact, some of the machines that made these parts I pass around, the machines in the factory make parts of themselves that go inside their machines. So it's like this type of idea of replication. You know, in fact, John von Neumann was the first person to write a whole book or so on replication, on self-replication, because he could see it coming. And actually, René Descartes in the 1600s also had some premonitions of replication, of self-replication. But anyway, so, and you also wonder what's coming next. And what's interesting is, 2,000 more years of this age of technology. I mean, it's going to be incredible. And I don't know if you've heard of the Lensman series. I mentioned it earlier for a different reason, of where he talked about people with incredible mental powers and things. But one of the things he didn't foresee was, this was written in the 1950s, and he had, and I did mention a little bit of this, but Doc Smith, he talks about the spaceship broke down between, in intergalactic space, and he's fixing his warp drive, and then he calculates his next jump through hyperspace with a slipstick, with a slide rule, And so think about, within 10 years, no one would ever use a slide rule again. And that kind of thing is just mind-boggling. Here's a futurist who couldn't foresee that. And I talked about some of those other people, and Jules Verne, who was able to foresee some things pretty accurately 100 years ahead of his time. But the stuff that's happening now is going so fast that some things are already in the works that are going to change the planet that we don't even understand yet. So things could be completely different in 10 years. That's why in my previous thing here, where was it? Ray Kurzweil, yeah. He was saying within 50 years or so, we won't even recognize ourselves. Things will be moving so fast. So once we get these nano factories, the desktop manufactories, the cost of every manufactured good might drop to the cost of dirt and sunshine, basically. Because it's all based on individual, individual elements that we use to make whatever we want. So this is what I want.
Productive nanosystems, from molecules to super products. Final production made possible by a challenge grant from Mark Sims and Nanorex Incorporated. Future advances in molecular nanotechnology will enable desktop appliances to manufacture products far better than today's best. The cartridges to the left supply simple raw materials to the machinery inside, here shown in schematic form. Products emerge from the top of this box, which holds the heart of the manufacturing system. Each product is built from beneath, layer by layer, by billions of tiny machines all working together. Near the top surface is the productive machinery itself organized into layers. Machines in the lowest layer process molecules into building blocks, passing them upward to machines that assemble them into larger components, and then to machines that add these components to the product. From a millimeter scale, 1 million nanometers, our view zooms in to the 10 nanometer scale. Each box is 1/10 the size of the one before. Here, at the molecular scale, nanomachines make small building blocks from molecular raw materials. The first machines sort molecules by their size and shape, passing some, rejecting others. Only molecules of the right kind can enter the processing machinery. These molecules contain 4 atoms, 2 of carbon and 2 of hydrogen. The molecules bind to a device that carries them to the next stage. Then, a rotating mechanism swings tool tips into contact with the bound molecules. Each tip presses a molecular tool against a molecule, bonding it firmly. The tools shown here have been analyzed using advanced quantum chemistry techniques. Another tool moves in from the left to remove the hydrogen atoms, leaving a pair of carbon atoms exposed and ready to use. The tools then carry these atoms to their destination, where each pair bonds to a nanoscale building block, making a tiny bit of crystalline carbon, a bit of diamond. Motions happen quickly at this scale. This scene shows motion slowed by a factor of more than 1 million. A conveyor carries the blocks past further machines, which build the blocks, step by step, to full size. Elsewhere, other specialized machines build blocks of different kinds. A system of conveyor belts and transfer mechanisms carries completed blocks from where they are made to where they are needed. This transfer mechanism moves blocks from one belt to another. The transportation system carries many different kinds of blocks, different shapes, different materials, different functions. It delivers them to the next stage of manufacturing. Here, a programmable machine lifts and places small blocks to make larger blocks. The small blocks bond on contact to form components containing millions of precisely arranged atoms. These can be simple structural bricks or intricate components for mechanical and electronic systems. The completed components are delivered to the final assembly stage, where many machines work together to build the final product. Motions at this larger scale are still quick. This scene shows motion slowed by a factor of 10,000. At the base of each machine, a transfer mechanism grabs components and lifts them from a conveyor. Each is flipped around, then carried up to the underside of the product under construction. Finally, machines lift the components and plug them in place, adding layer after layer to the bottom of the product. When the last layer is finished and construction is complete, the product is ready to be removed and used. The result of this production run is an atomically precise multiprocessor laptop computer with 1 billion times more processing power than today's best. The only waste products are warm air and pure water.
So this video was done by Mark Sims of Nanorex. He was on our nanomanufacturing tech group, and wonderful guy. And Eric Drexler worked as chief scientist for him at the time, and Eric Drexler is the founder of nanotechnology, and very quiet-spoken man, he wrote his first book was around 1986 or so, called Engines of Creation, and then taught the first course in nanotechnology at the time. So anyways, I wanted to show that to you because they put this together, and Eric Drexler being like the founder of the whole technology, so to say, he had the depth of insight to make this look pretty understandable, right? You kind of got an idea, even though this is, amazing that this is happening at the nanoscale, way down, that you can see how this could make things. And eventually, things will be made that way. Now, to go on, now some of the other things that are coming, that was also part of the stuff I was doing at the Nanomanufacturing Tech Group. One of our other friends was working on something like this, and it's called respirocytes, and this is where this replaces 10% of the blood, and it's 234 times more oxygen or CO2 than a normal blood cell. So the idea is that you wouldn't need to breathe for 4 hours. You would, because if you can hold oxygen in your system at the rate of 234 times more than normal, and also remove CO2 at 234 times the normal rate, then there's no need to breathe. And some people, when I had this, it was an interview of me some years ago, and on this stuff back east, and someone said, well, that's impossible, you'd have to breathe anyway. He says, no, you don't, because the medulla oblongata that some of us who are into yoga know, this is the place where everything starts. This is the where the ovum and the sperm unite to form the human body, very special place. But this is also a place that measures the respiration rate in real time. So it sees how much oxygen there is in the system, and it tells immediately whether the body needs oxygen or not. And so if you need oxygen, the medulla will make you breathe. But if you're full, like when you're in deep meditation and you go in the breathless state, it's because the medulla can see you're in a state of suspended animation where everything is completely the way it's supposed to be, and there's no need to breathe. And now the only thing, well, of course, one of the things I love to say is like when someone has got, if we had this and you had 10% of your blood as respirocytes and you have a heart attack, your heart stops, and says, oh, no problem, I've got 4 hours, so you call the hospital, hey, just have everything ready, I'm going to go, maybe have a drink or something, and just relax a little bit, and then I'll come over, or I want to do something fun first, or whatever, And also, if you go scuba diving, you don't have to worry about getting the bends. And I talked to, at USC, one of the people in the Department of Astronautics, where I'm active there, he kind of works with the astronauts, and he's a doctor, and he was telling me that the reason you wouldn't have to worry about the bends is that you're not going to be breathing down like 50 or 100 feet down below the surface, because when you're breathing from your tank there, that's when you can build up the nitrogen and have the problem. But if you go, if you just take a breath and hold it and then go down, there's no problem. And the thing is, if you can hold your breath for 4 hours, then you don't have to worry about anything. So it's kind of ideal that way. The only issue I have with the idea, I don't know how well it will work. One thing, again, that we're forgetting about in this coming into this new age is this materialistic approach that the blood is just nothing but a mechanism that handles oxygen. It's more than that. And I wanted to read to you Dr. Lewis, the Vice President of Self-Realization Fellowship, when he first met Paramahansa Yogananda, and Paramahansa Yogananda gave him that deep spiritual experience. This is what he saw. He says, Paramahansa Yogananda pressed his forehead against my forehead, and it was then that I saw the great light of the 1,000-rayed lotus, the most exquisite thing that can be seen with its many, many rays of silver leaves. At the bottom of the 1,000-rayed lotus, I could see, outlined in denser light, the walls of the large arteries at the base of the brain. And lo and behold, as I watched, little sparks of light inside the arteries were bobbing along, striking the walls as they passed before my vision. These were the blood corpuscles, each with its little spark of astral light, manifesting as it carried out its duty in God's play of light. Now, imagine, that's not just a little mechanism. Our blood that's filled with the light of God. It's filled with prana, with chi, with life force. And so there's a lot more to blood than just a little physical corpuscle, right? So I just wanted to point that out, that as we go further in this age, we're going to start working these things into our technology. And once we get way up towards the Silver Age, the Treta Yuga, then those things will be more important than the physical aspects. And now, I did mention this before a few months ago, but the nanotechnology using what's called utility fog or foglets. And so this Josh Hall was also working at Nanorex when we saw that movie, told you about Mark Sims being the president, and Josh Hall was hired as the chief technology officer for a while, and he's one of the pioneers in nanotechnology, and wrote a really good book which kind of takes the next step after Eric Drexler's book in the 80s, The Ancient of Creation. His book kind of takes it further from today onward of what we see coming in nanotechnology. Brilliant man. And see, he had this idea that if you see those look like atoms holding each other, it's really voxels, volumetric pixels. Just like you have your TV screen, you don't really see the individual pixels, right? And so in the same way, here, if you have utility fog, as he called it, you can't see the individual pieces because they're too small. They don't have to be nano-sized, though. They can be micro meters, and they hold each other. And if you have trillions and trillions of them all over the floor, then if they hold each other tightly, then it feels like a hardwood floor. If they loosen up, then it feels like a gushy carpet. But then if you have them as your walls as well, you can have TV images or anything moving across, on your walls and your ceiling. But then even more, let's say you wake up in the morning and your pajamas are made of foglets. Your bed is made of foglets, and so you invoke the daytime like you want this to be your living room now. So all of a sudden, all these foglets loosen up and separate and reform as a couch, as chairs, as tables. Your pajamas reform as a t-shirt and jeans or whatever you want, and everything switches around. And then your friend calls you from Australia, and you have the choice. Do you want to be in his room or does he want to be in your room? So I want to be in Australia. So all of a sudden your room reforms into your friend's living room in Australia. And he'll walk up to you and you can shake his hand. He's made of foglets, but it's like he's the real thing. You can, his hand feels normal, and then it's not a virtual reality. You're not wearing those 3D glasses or anything, because the couch you're touching, everything is real. Even your friend seems real, even though he's made of foglets. But the whole point is that then you could, say, okay, I'm going to play World of Warcraft, and all of a sudden everything in your house changes, and you're in this world that seems real, even though it's made of foglets. And now think about it in the future. If this sort of thing happens, then if a robber wants to steal something from your house, what would he steal? Because it's all just all these baubles and things that are mechanisms, all foglets, and they don't really have any value as such. The value is in the program that runs this whole thing. So he'd want to maybe, steal something off the computer, But so it kind of would change the whole way of thinking. And also then, because you reuse everything, like if your chair seems old, you just reform it, a new program from the internet that would, just have a different room every day, just whatever looks good on the internet. And so the idea of throwing things away that get old wouldn't happen anymore. And now, if you go a little bit deeper beyond this, you begin to see we can start manipulating atoms themselves rather than foglets. Eventually we'll go to atoms and manipulate them in the same way, right? To make whatever we want. Just like we have the nano desktop factory, right? So pretty soon we can make anything happen. Pretty soon we're materializing palaces in the Himalayas, right? And then we're getting more towards what Babaji was doing, right? And at this point it might still be a little bit more in terms of technology that's becoming more mental technology, but as we go into the higher ages, into the Silver Age, the Golden Age, then we're going to be starting to be able to materialize things the way Babaji did. So you see the transition, right? So we're in this age where we're beginning to see how all this stuff comes together and how it's all possible. So again, like, we're finding all these landfills right now, and all this, where do we put all this stuff? We're just contaminating the earth, because we're in this age where everything's going crazy and we're just brand new with technology. We don't understand all these things, that we're using up all these what we call fossil fuels and other things, because we haven't quite shifted over to using all the energy that's freely available. We don't have that down very well yet, but we will. So that whole idea of waste and landfills is going to be over. This is only a short period in the up and down going Dvapara, Yuga, Kali Yuga. That section is where you see those problems with all this waste and toxic things and all that stuff. That just, we get that taken care of. Just like you saw the Industrial Revolution, how horrible that was. That was the beginning of it. You saw the using the children, and how they had to work in these terrible conditions, and people were dying young because of the factories, the conditions and all that. See how far we've come from that, and we're now going to get past this stuff as well. So, and then this idea of programmable matter that we were just talking about converts also to programmable living matter through synthetic biology. So that's a whole new field, synthetic biology, which is another mind-boggling thing. So we, the idea is that robots of the future wouldn't be these metal things that we always talked about in the past, but they would have they would be grown out of similar things that our human bodies have, but they would be adjusted to have certain types of like stronger materials or whatever, but it would be very similar to us, but there'd be no soul, but they would have calculation abilities and things that would seem like thinking abilities, and but there would be a difference, and I don't know how much some of these things merge, because when you start looking at the control over DNA that we have now, where is that going to go, So the greater the power of the technology, the greater the responsibility that we have. It works hand in hand. And you can see we haven't used the atomic bomb again in over half a century. In fact, it's been 70 years. I mean, no one would have expected that. We used it once, or twice, so to say, and then when that was done, no one has succumbed to it again. That to me is quite a remarkable achievement. When a lot of countries have atomic capability, and yet we've controlled ourselves. We weren't able to do that before in the past. And we're having a hard time. There are wars and things. We still have a lot of things to learn, but somehow we're keeping it together. And technology isn't the cause of our problems. Unbalanced living is the cause. Spiritual maturity. So instead of searching outside, we should be searching within for fulfillment. So now let's stop at this point and take a break, and then we'll get into some really far out stuff afterwards.